Spartan fans, it is time to learn about hyperbolas, which are the last of the four conic sections. So let's review a parabola and an ellipse, and then we'll show you what a hyperbola looks like. So there are four conic sections. We did not talk about circles specifically in this chapter, and that's because I think you know what a circle is. You have the parabola. And the parabola is y equals a x minus h squared plus k. The vertex is at hk, or it's at x equals a y minus k squared plus h. The key distinguishing feature of a parabola is that either x or y is squared. One squared variable. Okay. Circle, ellipse, and hyperbola all have two squared variables. You have something like x minus h over a quantity squared plus y minus k over b quantity squared equals 1. All right. So if a is greater than b, then you have an ellipse, which is, wider than it is tall. A is greater than B. A is the major axis. X, right, left. So the ellipse is wider than it is tall. If B is greater than A, it's still an ellipse, but this time it is taller than it is wide. B associated with the y-axis, it's the denominator on the y variable, and y is vertical, so this is taller. If A is equal to B, well, it's not taller than it is wide, it's not wider than it is tall. This is a circle. And A and B represent the radius if they're the same. So now some of you would just want to know all these characteristics because you just, if A is this and B is that and blah, 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 blah. And so you prefer to kind of just memorize it. The thing we haven't talked about yet is a hyperbola. So one squared variable, parabola. If A and B are the same, circle. If A is greater than B, it's an ellipse. B is greater than A, it's an ellipse. What is the distinguishing feature of a hyperbola? And the key distinguishing feature of a parabola is subtraction, and that overrides everything. One squared variable, parabola, move on. If it's subtraction, hyperbola, move on. And then you've got to figure out the ellipse, and it has, its distinguishing features. So for a hyperbola, again, it's x minus h over a squared, and it's y minus k over b squared, and it equals 1. Who cares what a and b are? If this is minus, right away it's a hyperbola, even if a and b are the same value. Your other option is that it could be negative x minus h over a squared plus. That is still subtraction. It's just written in a different order. This is still subtraction. X is positive, X is negative. So if X is positive, this is going to open in the X direction. It's a hyperparabola. There's two of them. There's two parabolas. If X is negative, that means Y is positive. Y is the vertical. So it open up, down. You might want to pause the video and or go back and watch, just kind of listening to all the features. All right, let's graph a hyperbola. It is sometimes difficult to tell just looking at the equation. You know, is this a hyperbola? Is this an ellipse? Let's go for it. I will say this, when you look at the initial equation, and if there's only one squared variable, then it's a parabola right away. One squared variable, parabola right away. Okay, so we're going to complete the square to write it in standard form. Oh, actually, I think they call it, this is vertex form, and this is called standard form. This one up here is vertex. This one right here in green is standard. I'm going to group the x's and I'm going to factor out the 2. Careful. I'm going to group the y's and I'm going to factor out the negative. Be careful, be careful. If you were to distribute the -1, right, that's a -1. Negative y squared plus 4y. This will really mess up the center of your hyperbola if you get this subtraction wrong right here. Okay, so let's see, complete the square. So that is +1 and this is +2. Complete the square and this is +4, I believe. Yeah, and then this becomes -4. All right, so this is 2x plus 1 squared minus the quantity y minus 2 squared is equal to 2. This 2 is icky, but I'm going to divide everything by 2, and this is going to give me x plus 1 squared minus y minus 2 squared over 2 is equal to 1. We're going to come back to this. Well, actually, no, we're here. Let's do it now. I tend to put the whole quantity in parentheses. So I don't care which way you do it. Like, I think your book does separates the numerator and the denominator and squares them. And I tend to write it as one large quantity. This 2 is not very fun, and we are definitely not going to rationalize. So I am going to rewrite it this way. And I'm only going to do it temporarily. Okay. Good news is this hyperbola opens in the x direction, so I'm not going to have to use that root 2 very much. Okay, so x is positive. So this is going to open in the x direction. So this is an x direction hyperbola. It goes right and left. Technically, right, this is over 1. And root 2 is greater than 1. Who cares? Who cares? It's what's positive, and that's the direction that it opens. Okay, so the center of this hyperbola is -1, 2. This hyperbola has vertices. A is 1. So this has vertices, right 1, left 1. So let's just graph it first. I think that's helpful for many of you. Some of you freehand on your homework and it just doesn't look very nice. Use a ruler. Graph paper doesn't do you any good if you're approximating everything. So my center is at -1, 2. That's here. And then my vertices, I'm going to move 1 right, 1 left. There are no covertices on a hyperbola. There are no covertices, just vertices. So this is going to be what? 0, 2, and negative 2, 2. Ha ha ha. Negative 2, 2. So now the question becomes, how wide do the parabolas, the total hyperbola, how wide is it? So is it like such? Is it like such? So if you recall, we need to find the asymptotes. Okay, asymptotes are lines. Lines have a slope. This pencil does not erase. There we go. Okay. Hyperbolas have asymptotes. Asymptotes are lines. Lines have slope. How do you figure out the slope? Slope is rise over run. Slope is rise over run. No matter what, your whole math life, right? Like we're advanced now, we don't say rise over run, but it's going to help you. The rise is always y. The run is always x. The rise is always y. The run is always x. I don't care which variable is bigger. Not variable, sorry. I don't care which denominator is bigger. I don't care if it opens right, left, up, down. The asymptotes are found the exact same way. Rise over run, y over x. So the slope is going to be, and it's plus or minus because there's going to be two of them. The denominator associated with y is root 2. And the denominator associated with x is 1. I'm just writing that so you can see how I got the root 2. This is the slope. This is not the asymptote. This is the slope. Okay, great. Well, lines are equations. So you have slope, you have a point, use point slope form. You have slope, point, point slope form. So the asymptotes are at y minus 2 equals plus or minus root 2 x plus 1. All right, how am I going to graph this? I have to approximate from the center, from the center, from the center. Root 2, whatever, 1.4. My center is right here in the middle. So up 1.4-ish, right 1, up 1.4-ish, right 1, down 1.4-ish, left 1, down 1.4-ish, left 1. And then you have this great little shortcut to finding the remaining points. I don't know if you can see this, but from the vertex, went up 1.4, down 1.4. So this is maybe helpful for some of you. You can draw this little rectangle, which helps you find other points, or you can just plot from the center up 1.4, left 1, down 1.4, right 1. But essentially, I'm just graphing two lines. This hyperbola opens very wide. You need to make sure you are approaching the asymptotes. So if you're asked to graph this on the final, which frankly I don't think you are, but if you are, you better make sure that you are approaching the asymptotes. I don't think you're asked to graph these on the final, or there's too much other information to put on there. This should not be going back up. This really should be going down more. I'm not going to white out my hyperbola. Cool. We have asymptotes. We have vertices in the center. And of course, we are missing foci. So the foci for an ellipse, you subtract. Foci for a hyperbola, you add. Who cares which one's bigger? So when I was doing the ellipse notes, and I said you have to make sure you do the larger minus the smaller. I think my ellipse notes are right here. Yeah. The ellipse notes, you have to do the larger minus the smaller denominator, larger denominator, smaller denominator. Otherwise, you're going to get a negative. Who cares for a hyperbola? Because for a hyperbola, it's addition. You don't have to worry about getting any negatives. So this is foci. So for this particular problem, c squared equals 1 squared plus root 2 squared. That's what, 3. So c is plus or minus the square root of 3. Okay, from the center and in the x direction. So I've said before that foci need to be inside of the curve. So my foci need to be here somewhere, so that if I took the hyperbola and I smashed it down, I would smash the foci. Okay, so from the center, from the center, from the center. So the center, the x coordinate is -1, -1 plus or minus root 3. Oops, that should not be a parenthesis there. Of course, it's not working. Sorry. What the heck? Oh, all right. I can't get the whiteout to work. -1 plus or minus root 3. And then the y value of the center is 2. So where do those go? Root 3, 1.7, really close to my vertices. So 1, -1 plus root 3 is like here-ish, and -1 minus root 3 is like there-ish. And those are your foci. That is a hyperbola. I'm going to give you the information for the hyperbola, and we're going to write the equation in vertex form. So I'm going to tell you that the center is at -3, 1. Right away, this is at x plus 3 over something squared plus y minus 1 over something squared. Doesn't matter which way it opens, the center is the center. We have a focus at -3, 6. That means that from the center to the focus, I moved 5 in the y direction. Okay, so that means that c is 5. And this means that y is the positive variable. So y is positive, x is negative. Foci always go on the foci are always inside of the function, inside of the graph, so to speak. So foci are in the y direction, therefore y has to be positive. There's a vertex at -3, 4. Okay, so from the center, we moved 3. From the center, x stays the same. 1 to 4 is 3. So that means that, let me write this down. From center to vertex is 3. And how about I just write this down as well? From center to focus is 5. This says 5. Okay, so now I know x plus 3 over something squared plus y minus 1. Well, I know my something. From the center to the vertex is 3. Okay, if from the center to the focus is 5, that means that C is 5. C squared is 25. Whatever, I'll call it A. Purple, whatever, who cares? A squared plus 3 squared equals 25. Formula for the foci, I'm just plugging in. What do we got here? A squared is 25 minus 9, 16. Oh, it's a 3, 4, 5. A is 4. That is the denominator on x. Negative, 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 because it opens in the y direction. X has to be negative. Don't you dare distribute. A is 4. Notice that the x denominator is greater than the y denominator, but it doesn't matter. For hyperbola, it doesn't matter which one's larger. It matters which one is negative. This is one way you can write it. If you want to write it as y minus 1 squared over 9 minus x plus 3 squared over 16 equals 1, that's totally fine. I don't care which one you do. I like to put it this first way because then I don't overlook, because we're so used to x being first, then you don't overlook the fact that, oh, it's x that's negative. That is working backwards. And that is Crash Course in Hyperbolas. I would focus on making sure that, if I were studying this, I would make sure that I understood parabolas have one squared variable, hyperbolas have subtraction. So the parabola, one squared variable, boom, overrules everything. Hyperbola, if it's subtraction, that's the next in line. If it's subtraction, I don't care which is bigger, A or B, who cares? If it's one of them is negative, right away it's subtraction. So those are some key characteristics that I would be reviewing.